Very good evening, everyone. In this video, we will try to understand some of the fundamental concepts related to gas welding process. So to begin with, we'll first see the definition of gas welding process. Then we'll see the construction of gas welding setup. Then we will see the working. Followed by that, we will try to understand types of flames that are possible in gas welding process, and then we conclude with advantages, disadvantages, and applications. So basically this gas welding process comes under the category of fusion welding process. So we know what is fusion welding. So in fusion welding, we try to join two metals with the help of heat and heat the metal above the melting point, and then we fuse them together at metallurgical level. So this same thing happens in gas welding process. So next question is how we get heat in gas welding process. So the answer is that we will get the heat by the combustion of two gases. One is the fuel gas, mostly it will be acetylene in most of the cases with respect to gas welding process, and then oxygen. So through the combustion of these two gases, we will get the heat. That heat will be made to contact the workpiece that are supposed to be joined. Then fusion will take place. So this is what happens in gas welding process. Here also we will protect the weld from atmospheric contamination by the usage of flux. As we know, during welding the metal will be subjected to heat. When the material is at high temperature, it shows more affinity towards atmospheric gas interaction. This will result in some formation of inclusions, porosities, which in turn affect the overall weld quality. So in order to prevent the interaction of the weld from atmospheric contamination, we will try to use this flux as we have seen in sealed metal arc welding. So this flux will melt during the welding process and it will form blanket and it will get deposited as a slag. So this slag, once it is welding is done, we will remove it with the help of chipping hammer, as we do it in the shielded metal arc welding process. Now we will see the construction aspects of the gas welding process. So as you can see it in this picture, we have two cylinders, one containing acetylene, another oxygen cylinder, and then we have this gas torch, and then valves for controlling the flow rate of the two gases, and then we have this workpiece, and this is the flame which is heating the workpiece. Okay, so to identify the type of gas that is available in a cylinder, we can identify through the color. Generally oxygen cylinder will be in black color, and then this acetylene will be in maroon color. So maroon color, it will be in maroon color. So through the color we can understand what is the type of gas that is available in cylinder. Coming to the working of this gas welding setup, so this with the help of flow control valve, we will try to control the volume of acetylene and oxygen, and this oxygen and acetylene will be mixed in the mixing chamber. This and it will be made to pass through this gas torch. Then we will be having a striker which will ignite this oxygen and acetylene. As a result of that, we will get a flame. That flame will be made to touch the workpiece so that it heats the workpiece, so that we will be able to join them at metallurgical level. So here the schematic of welding can be seen in a detailed manner in this picture. You can see here we have this nozzle, gas nozzle. This is the flame, this is the workpiece, and you can see that molten metal, which which was created through the flame. This is the welding direction. Okay, so you can see here there is a filler rod. If you want to deposit any additional material for the purpose of alloying or for just filling the material, we can use filler rod, which will be coated with the flex. As we have seen before, this flex will help us to protect the weld from atmospheric contamination. So this is the construction and working aspect of this gas welding process. So based on the volume of acetylene and oxygen, we can have three types of flames in this gas welding process, namely neutral flame, then reducing flame, and then we have oxidizing flame. So based on the volume of oxygen and cylinder, we have these three types of flames. In case of neutral flame, the volume of oxygen cylinder, it will be in the ratio of 1:1. So we'll be using same volume of oxygen and acetylene. Whereas in case of reducing flame, acetylene content, volume of acetylene will be greater than volume of oxygen. So that is the case with respect to reducing flame. Whereas in case of oxidizing flame, volume of oxygen will be greater than volume of acetylene. So that is, we will use more amount of oxygen in case of oxidizing flame. So depending upon the type of flame, the temperature varies, and accordingly the application aspect of the gas welding also changes. Okay, so you can easily distinguish these three flames based upon the appearance of the flame. For example, in case of neutral flame, as shown it in the figure, we will be having a small inner cone and will be having a outer envelope. Okay, so most of the heat, that is 2/3 of the heat, it will be because of this inner cone, and 1/3 of the heat will be through this outer envelope. So let's see what is the reaction that is generally happening in this gas welding process. So we'll be having acetylene and then oxygen, so it will give us carbon monoxide and hydrogen. So this reaction happens in the inner cone. This is the primary combustion. So the product of the primary combustion will interact with the atmospheric oxygen and it will form carbon dioxide and water separately. So that reaction for that is as follows. So this O2 is from air, which will give us 2H2O. So this reaction happens in the outer envelope. Okay, so this is the two reactions that we generally see it in the neutral flame. So here this combustion gives 2/3 of heat. This will give 1/3 of heat from the flame. Okay, and in case of this reducing flame, where the acetylene content is little bit higher than the oxygen content, we have an additional greenish acetylene feather. Greenish acetylene feather. So if we have an additional greenish feather, then we can understand from the color of the flame itself, it is having more amount of acetylene. Because of that, we are getting this greenish feather. So this kind of flame, we will see it in the reducing flame. Whereas in case of oxidizing flame, where we have more amount of oxygen, we will be having a short white inner cone. This short white inner cone will be the significant feature of this oxidizing flame. So if you see the temperature aspect of each flames, oxidizing flame temperature is greater than reducing flame. Sorry. Oxidizing flame will be having the maximum temperature. It will be in the range of like 3482 degrees Celsius. Then for in case of neutral flame, the temperature of the inner cone will be around 3232 degrees Celsius, whereas this reducing flame, where the acetylene content is more, the temperature will be in the order of 3149 degrees Celsius. So as you can see, oxidizing flame will be having the higher temperature, followed by that neutral flame, then finally reducing flame. So this neutral flame will be generally used for joining mild steel, stainless steel, cast iron, this neutral flame will be used for joining these materials. This reducing flame will be mostly used for joining aluminum, and this is not used for joining any metal that readily reacts with carbon. So we have to avoid this reducing flame for joining steel and iron, whereas this oxidizing flame oxidizing flame will be used for joining brass, as this copper oxide will be formed. This will act as a shielding and protect zinc from evaporating. So based upon the material, we can select the different types of flames just by changing the volume of the oxygen and acetylene content. So these are all the important aspects of these types of flame. Next we'll try to understand some of the advantages. So the setup is very simple, portable, can and it is not that much costly, inexpensive. It is mainly used for repair work. As it is portable, we can take it to any location in case of any repair. We can just use this gas welding to repair that particular spot. Coming to the disadvantages, power density is very less, heat input supplied will be more, that is how much joule per mm, that will be very high. As a result of that, we'll have bigger HIZ, and distortion also will be more. So these are all the general disadvantages, and they are not generally preferred for joining reactive metals such as titanium and zirconium because of the process characteristics. So application aspects, as discussed in the types of flames, depending upon the type of flame, we can join aluminum or brass or this ferrous based material. To summarize, we have just understood what is gas welding, and we have seen what are the construction aspect of gas welding, and then working principle, and types of flame based upon the volume of oxygen and oxygen, and we have seen the advantages and disadvantages, and the reaction that generally occurs in inner envelope as inner cone as well as outer envelope, then advantages, disadvantages aspect of gas welding. Thank you very much for listening. See you in the next video.